Hi, I'm Jason McCoy, Product Manager of Sprecher+Schuh, and I'm here today to provide you a demonstration on how Sprecher+Schuh's CEP7 ERID remote reset module can benefit your customer with a specific need. We have a CEP7 ERID module installed on a small 3-component Type E combination starter, which I'll explain at a greater detail a bit later. The CEP7 ERID module allows you to remote reset the CEP7 EE solid-state overload, which this is the automatic manual version, while including the extra features of an LED indicator for 4 conditions, and they are display status indicator, overload condition indicator, phase loss indicator, module fault indicator. Also, here is the blue reset button. The display status indicator in the upper left corner will give a flashing green light when a side mount module is powered and functional. When the motor starts to run and there is current flowing, the flash turns to a solid green light. The upper right corner of the CEP7 ERID offers an indicator for an overload condition. This indicator provides the feature of an impending overload by shining a yellow flashing light, which means that an overload has not quite yet occurred, but if the application were to continue as is, then an overload is going to be an impending event. If an overload condition actually occurs, then this will be a solid red light. The lower left corner of the module will shine a solid red light if the overload were to trip due to a phase loss occurring on a 3-phase system. The lower right corner provides an indication for the type of fault as occurred. This resets the type of protection module you will install. For the example that we have here in this assembly, we are using the CEP7 EPT side mount module, which is the unit that measures PTCs for thermistor protection. As an overall description of the panel as a whole, what we have here essentially is a 3-component Type E combination starter. Up under this disconnect handle is a KTB motor circuit controller, which is a magnetic-only device since the overload protection will be handled by the CEP7. In line with the controller, we have a contactor and overload with the CEP7 EPT side mount module. The objective of this working sample is to simulate several different types of faults. And with this 4-position selector switch, we will recreate a thermal overload, an over temperature condition in the PTCs, a PTC open circuit, and a PTC short circuit. We can accomplish these different conditions by adjusting our attached motor load and through the use of specifically selected resistors inserted into the terminal blocks wired in the circuit. Let's start the demonstration by noticing that there are no LED indicators lit up on the CEP7 ERID reset module. Once we turn the KT7 handle to the on position, we see there is a flashing green light in the display status acknowledging that we now have power to the unit. With power applied, we can begin the operation by pressing the start button. With our operation running at low speed, we see that the flashing green display status has changed to a solid green light, which means that there is now current flowing. At the low speed setting, our load is drawing approximately 3.9 amps, and the CEP7 is set for 5 amps. Everything is working smoothly because there are no other indication lights shown. However, if we were to change our selection to medium speed, we now notice that the overload condition light is flashing yellow. The yellow flashing light means that there is an impending overload condition that is going to happen if we continue operating under these conditions. At medium speed, the load is running at approximately 6.1 amps. Now, if we were to take it one step further and run our operation at high speed, we are now running at approximately 13.2 amps. The indicator had already told us that we had an impending overload at medium speed, so at a high speed, at 13.2 amps, we find ourselves working through a time current curve with the expectations that an overload trip will occur. We go back to the reset module to check our indications, and we see that the flashing yellow light has turned into a solid red light that recognizes an overload condition has occurred. We want to reset our operation, so I'll return the load back to the low speed, and then I'll press the reset button once on the ERID. We have just simulated an overload condition. Now, let's go to the next type of fault, which is going to be a PTC over temperature trip. With the operation running smoothly, I'm going to switch over to simulate an over temperature from the PTCs in the motor. What we have done here is use a resistor in the circuit that exceeds the ohm values that the EPT thermistor relay considers normal. As we go to the ERID to check the fault indication status, we see that there is now a flashing red light in the module fault area. How it works here is that the ERID will flash a number of times to imply what type of fault that has occurred. One flash is for ground fault, 2 flashes is for a jam trip, and 3 flashes is for a PTC trip. Now let's count the number of flashes on the ERID. How many flashes do we have? 1, 2, 3. 3 flashes tells us that we've just had a PTC fault, and there is a CEP7 EPT mounted to the side of the overload inside the box. Normally, the technician would have to open up the enclosure and then count the number of flashes on the module itself to find out what type of PTC fault, but since we have the clear cover enclosure to see through, let's look at the side module and count the number of flashes. 1, 2, 3. Now that we know there are 3 flashes on the module, we then refer to the EPT instruction sheet or technical section of the catalog to find out that 3 flashes means that there has been a PTC trip, which reflects an over temperature in the motor. Let's reset the operation again, and I'll hit the reset button once. One would consider what kind of detection we really have here with the ERID, so let's question if it would detect heat in the motor even without the operation running. Even without pressing start, we see that the ERID already has detected a fault. Let's reset the operation again, and I'll hit the reset button once. So far we have seen 2 types of fault conditions. Let's move on to our next fault, in which we'll simulate an open circuit condition from the PTC chain. I'll hit the start button. With the operation running smoothly, I'm going to switch over to recreate the open circuit. Again, we see that the ERID recognizes a fault with a flashing red light in the module fault area. There are 3 flashes on the ERID, which tells us that a PTC fault has occurred. By looking through the cover, we now count the number of flashes on the side mount module. 1, 2, 3, 4. We then refer to the EPT fault legend and find that 4 flashes mean that the condition is a PTC open circuit. We have simulated the open circuit. The side mount module recognizes that there is a problem and provides us with the correct fault assessment. Let's reset the operation again. And I'll hit the reset button once. Now that we have sampled a couple of fault conditions, let's move on to the last simulation. We're going to recreate a short circuit. I'm going to hit the start button. With the operation running smoothly, I'm going to switch over to recreate a PTC short circuit. Again, we see that the ERID recognizes a fault with a flashing red light in the module fault area. There are 3 flashes on the ERID, which tells us that a PTC fault has occurred. By looking through the cover, we now count the number of flashes on the side mount module. 1, 2, 3, 4, 5. We then refer to the EPT fault legend and find that 5 flashes mean that the condition is a PTC short circuit. Let's reset the operation again, and I'll hit the reset button once. Now, we simulated 4 different fault conditions and have shown the unique features that the CEP7 ERID can offer. The only other feature of the device that we did not demonstrate is its ability to detect a phase loss. Being that we are plugged into 120 volts into the wall here, a phase loss condition is not possible. The CEP7 ERID is small in design and is connected with twisted pair wire, and has the capability of being mounted up to 200 feet away from the module. The mounting of the ERID is done through a standard 22mm push button type of hole with a single fixing nut. We offer remote reset modules, jam protection modules, ground fault modules with CTs, ground fault and jam protection modules, and PTC modules, which we've demonstrated here. All of these modules interface with the ERID remote reset. If you or your customer has a need for a remote reset with indicators and also have a requirement for a specific protection need, then the CEP7 ERID is the product that you're looking for.